In this lesson, we are going to see an introduction of how Tabular Data Stream Protocol (TDS) is used by a SQL Server and inspect into TDS packet layout, analyzing some packets obtained from the network. The Tabular Data Stream (TDS) Protocol is an application-level protocol used for the transfer of requests and responses between clients and database server systems. In such systems, the client will typically establish a long-lived connection with the server. Once the connection is established using a transport-level protocol, TDS messages are used to communicate between the client and the server. The Tabular Data Stream (TDS) Protocol depends upon a network transport connection being established prior to a TDS conversation occurring. The choice of transport protocol is not important to TDS. TDS depends on Transport Layer Security (TLS), Secure Socket Layer (SSL), for network channel encryption. Although the TDS protocol depends on TLS/SSL to encrypt data transmission, the negotiation of the encryption setting between the client and server in the initial TLS/SSL handshake are handled in the TDS layer. TDS session is directly tied to the transport level session, meaning that a TDS session is established when the transport level connection is established, and the server receives a request to establish a TDS connection. The current version of the TDS protocol has implementations over the following transports. TCP, by default, uses 1433 port. A reliable transport over the Virtual Interface Architecture (VIA) interface. Name pipes. Shared memory. In this slide, you can see typical flow of communication in the TDS protocol. Each TDS packet begins with an 8-byte header with the following fields. Type defines the type of message. Type is a 1-byte unsigned char. If an unknown type is specified, the message receiver should disconnect the connection. Status is a bit field used to indicate the message state. Status is a 1-byte unsigned char. The following status bit flags are defined. 0x00 normal message. 0x01 end of message, EOM. The packet is the last packet in the whole request. 0x08 reset connection. 0x10 reset connection skipped RAN. Length is the size of the packet including the 8 bytes in the packet header. It is the number of bytes from the start of this header to the start of the next packet header. Length is a 2-byte, unsigned short end, and is represented in network byte order, big-endian. SPID is the process ID on the server, corresponding to the current connection. This is a 2-byte value and is represented in network byte order, big-endian. Packet ID is used for numbering message packets that contain data in addition to the packet header. This value is actually ignored. Window this 1 byte is currently not used. This byte should be set to 0x00 and should be ignored by the receiver. The messages contained in packet data that pass between the client and the server can be one of two types, a token stream or a tokenless stream. A token stream consists of one or more tokens, each followed by some token-specific data. A token is a single byte identifier that is used to describe the data that follows it, and contains information such as token data type, token data length, and so on. Tokenless streams are typically used for simple messages. Messages that might require a more detailed description of the data within it are sent as a token stream. More complex messages, for example, col metadata, row data, and data type data, are constructed by using tokens. As previously described, a token stream consists of a single byte identifier, followed by token-specific data. Significative tokens may be column definition, row data, data type. There are also zero-length tokens, which actually are 1 byte length of the token ID but it has no data associates. These tokens are mainly used to denote the end of certain operations, such as a query response. Now we are going to capture SQL Server client-server communication packets. As root, execute command tcpdump to capture traffic for port 1433 and save it to a file. In another shell, use mssql CLI command to send a query to the HackDB database. Now, we open the pcap file obtained sniffing the network with Wireshark. Selecting in the Statistics menu option the flow graph function, we can see the flow of packets between the SQL server and the client, also indicating the type of each packet. With Wireshark, we can easily analyze DDS packets. This example in the slide corresponds to a query sent from client to server. At the beginning of the DDS packet, there is the packet type byte, which indicates that this packet corresponds to a SQL batch message. Then there's the rest of the packet header. In the packet body, DDS packet query, we can see information about the type of operation sent to the server, and at the end of the packet the query sent to the server. This example in the slide corresponds to a query response to a select query. At the beginning of the DDS packet, there is the packet type byte, which indicates that this packet corresponds to a response message. Then there's the rest of the packet header. As we can see, this packet is from token stream packet. The packet body is composed of several tokens. First of them is to describe the columns obtained by the query, and the rest of tokens are the different rows returned by the database, representing each token a different row. Metadata token is 0x81, and contains the number of columns, and for each column its type, name length, and name. Row token is 0xD1, and includes for every field in a row the value length, and the value itself. Done token is 0xFD and contains no data.